There's a way indeed. Let's now study what we call modified condition decision coverage, or MCDC. Let's go back to our example with 3 conditions. And that's the truth table we have for this logical expression. If the 3 conditions are true, the outcome of this entire expression is true. If A and B are true, but C is false, the outcome is also true. And so on and so forth. Now the question is, how can we identify the useful combinations to test? The idea here is that we will exercise each condition that could independently affect the outcome of the entire decision. You will understand it once we get started. Let's start with A, the first condition. In the first row, we see that when A is true, B is true, and C is true, the outcome is true. Okay, now we need to see what happens when we flip A, but keep the other conditions the same, meaning A false, B true, and C true. Let's search for this row in the truth table. Yes, line 5. See, the only condition that changed was A. But the outcome changed as well. This means that our software would take one path if A is true, B is false, and C is true, but another one if A is false, B is true, and C is true. This means that tests number 1 and number 5 are good tests for us. And usually, a single pair of tests per condition is enough. After all, we already found a way to exercise that condition in an independently way. But let's continue, because at the end, having all the possibilities will help us to minimize the total number of tests. Let's now repeat it for row 2, which is A true, B true, and C false. Its counterpart is row 6, where A is flipped, false there, B is still true, and C is still false. And look at the outcome. They are also different. So we just found another case in which the system would behave differently if A changes. Let's keep them as well. Next, row 3. We have A true, B false, and C true. Its counterpart is row 7, where A is flipped, B is false, and C is true. The outcome is also different, so we keep this pair as well. Now, for row 4, its counterpart is row 8, but the outcome is the same. Both are false. So this means that A, in regards to test 4, true, false, false, and to test 8, false, 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 does not independently affect the outcome. In other words, for A, these 2 tests are not that interesting. Okay, let's go to condition B now. First row, B true, outcome true. Now we find the row where all the conditions are the same, but B is flipped, meaning true, false, true, which happens in row 3. As the outcome is the same, tests 1 and 3 are not that important for B. Now we move to the next row, true, true, false. Let's look for the row where we see the same conditions, but with B flipped, which happens in row 4. And the outcome is different, meaning tests 2 and 4 are a good way to independently test the behavior of B. This means these 2 are good tests to make. We can continue this process for the other rows. Actually, you can pause the video now and try it by yourself, but you won't find another pair of tests where the outcome is different. Finally, condition C. Rows 1 and 2 are the ones with C flipped, and the outcome is the same, so not interesting. Then we see that in row 3, A true, B false, C true, and row 4, A true, B false, C false, the outcomes are different, so we add them to our list. And that's also it for condition C. Now, if we see all the tests we should do, we have for A 3 options, test 1 and 5, 2 and 6, and 3 and 7. For B, the only option is 2 and 4, and for C, 3 and 4. Now we should try to minimize the number of tests. Take a look. If we actually execute tests 2, 3, 4, and 6, we are actually executing a pair for A, for B, and for C. Great, 4 tests instead of 8. And actually, I'm not gonna prove here, But with MC/DC, we always need only n plus 1 tests, where n is the number of conditions we have. In the example, our n was 3, after all, A, B, and C, and thus the number of tests is 4. This is definitely better than 2 to the power of n. So, we just learned the MC/DC coverage criteria, which is common in some industry like avionics. MC/DC gives us a manageable number of tests to perform when the number of combinations is too high.